Hello, everyone. Thank you for joining us in our 2025 Snack and Learn webinars. Today, we'll be talking about achieving early systems integration by applying a digital engineering framework. We welcome you and we remind you that we will have the presentation and then we will have time for Q&A at the end of the session. So please drop your questions in the chat box. We will read it at the end. And for now, I will pass it on in our expert, Oliver Hine.
Thank you. Can you hear me okay, Kata?
Yes, we can hear you.
Okay. Very good. Well, then, thank you for your interest and taking time out of your busy schedule. So we have a lot of ground to cover, so let me just get right into it. So what I would like to do is break the presentation down into a couple of subtopics. The first one, we are part of, we're working in transportation infrastructure. So applying digital engineering is a solution, right? So we first need to understand why are we doing this and what challenges are we facing. Then I will look at those challenges from a systems engineering perspective and then move on to the digital engineering approach, which in our industry would be the model-based systems engineering, and then walk you through the actual approach and then conclude with a summary and some final words. Moving on. So in the transportation infrastructure industry, systems engineering is still somewhat immature, but there are some good documents. One of them is when you're looking at systems engineering for intelligent transportation systems. It identifies the life cycle. I'm sure if you're in the systems world, you have seen or heard this before. And the traditional life cycle is really focusing, even though you see 5 boxes over here, 3 belong to the typical project like preliminary engineering. This is often referred to final design and then construction, and then project initiation and closure are typically done by the owners of a project. Anyway, the industry refers to that as plans, specs, and estimates. Let me show you. So if you go, for example, to the Federal Highway Administration website, you will see the plan, specification, estimates. And the whole idea is to create those in order to start with construction. So everything is really geared towards construction. The focus is always on getting done with a quote-unquote paperwork as quickly as possible to start construction, right? If it's not, if there are no shovels in the ground, then it's, people get very upset. So what are plans and specifications and estimates? So plans are actually drawings. As in every industry, you will have to learn a little bit of nomenclature and how things are being named. So what you see here is a rail, right? The profile of a rail as a drawing, and you can already see that this describes technically the solution. It's not really requirements. It says this is a rail and with all the detail, right? The distances, and then you have supporting specifications. They are the specs, and they're typically broken down into 3 parts. The first part is a general overview, qualities, the middles, and then the second part is the products. So in that case, you actually describe the rail. And the third part would be the execution, which describes how to actually perform the work. Preparation, can you see, installation, also inspection, quality testing, you name it. And so if you have to, if you align those phases to the V life cycle, again, coming directly out of this document over here, the preliminary engineering would cover the upper left of the V life cycle, as you refer to it, and it would refer to the concept of operations, the system requirements. Then the plans and specs refer to the high level and detailed design, but as you can see, it's already design. And then obviously construction will be the right side of the V, right? And then ideally, during preliminary engineering or conceptual design, you would identify the requirements and not the solution. However, having said that, we just talked about the plans, specs, and estimates. They are all about solutions. So already you have one of the first challenges in the industry that this whole approach is really more geared towards the final design of a high level and detailed design. And then we have other challenges I will get to in a second. This one is another one. Typically, owners, clients, or even our own organizations are grouped by functions. So you have departments, for example, you have planning, operations, maintenance, IT, engineering, safety, you name it, right? And they're typically grouped that way because you have subject matter experts that fall into that category. Then engineering, as an example, is further broken down into disciplines. So you have civil engineering, structural engineering, mechanical, electrical, communications, right? You can see. And then further, once you go to communication, as an example, you would have networks, phones, intercoms, radio, CCTV, which are cameras, public address. And then the next and final step would be how to basically apply this to the actual sites, right? The industry refers to sites, and those would be facilities like stations, control centers, wayside or trackside, sometimes called onboard, on vehicles, on buses, trains, you name it. If you have not heard of it, there's Conway's law from the 60s, right? And so what he did is he said organizations which design systems are constrained to produce designs which are copies of a communication structure. And so what does this mean? Is, if we just recall what you said, looking into an organizational breakdown structure, you would see engineering, civil design, right? Or civil engineering, structural engineering, geotechnical engineering. And what this means is you will get exactly those type of submittals, right? So I give you an example. This is taken from one of the projects I was working on for quite some time. And full disclosure, all of the information you see here is either publicly available or was already shared before. So there's nothing that I'm divulging into the public that should not have been shared. So, but what you see over here is civil, right? So you get a civil submittal, then you get a structural submittal, and then you get a geotechnical submittal. And because, right, it's really based on the organizational structure. So if you want to change that, you really have to change your organizational structure. And then obviously you have other submittals. And so this is design, but what I've found really, really interesting over all the years is that continues during construction. So this is the structural construction, right? You see concrete and steel, and that's pretty much the structural design. Then later on, you have geotechnical, in this case, the earthworks. I'm sorry, this is the retaining walls, and then the earthworks later on, right? That's a civil design. And so what happens is the actual integration happens really in the field or at the end, during construction, after construction. And that I find, I mean, this picture alone, right, of the structure sitting here is kind of a good way to think of why we have so many challenges when it comes to systems integration in our industry. And the idea is really, right, to bring this to the front. And anyway, so let's move on. So what happens now is, if you see the life cycle over here, preliminary engineering plans, specs, and estimates, and construction, and then you see the organizational structure. If you combine it, what really happens in reality is once a project starts, and it can be at any stage, it could be preliminary engineering, final design, construction. What happens is all of those disciplines kind of work in parallel. During final design, during construction, and what happens during those phases, obviously it has come to the attention of many participants in the industry that systems integration is an issue, but the way to solve it is by quote unquote coordination, right? So the idea is just saying, hey, you guys talk to each other, and that works to a certain degree, but not always the best way. And then construction, then, and at the end of the day, when you start to integrate, then the question is, when you want to go to operations maintenance, are you really able, right, once you have proceeded with all of the different disciplines, to come up at the end with an integrated, safe, secure, operable, maintainable, and reliable system? And the answer is, unfortunately, quite often not exactly. So this is one of my favorite pictures. So what you see over here, right, you see the structure of a car, you see the mechanical discipline. With HVAC, you see the power, you see communications. So this is about building the system right, making sure you can actually integrate at the end. But you cannot integrate if the system was not designed to be integrated. Otherwise, you just have to use a lot of duct tape and glue and hopes, I guess. But even worse, if it comes to operations. So if your plan was to design a system where you can dial 999 for Coast Guard, but then you get a solution that doesn't even have a 9 on the touchpad, then you're in trouble. So this is about building the right system. And so I'm not sure how obvious it is, but there's a difference between building the system right against the specs and then building the right system, making sure that you have really understood what you're trying to do here. So what does it mean to a systems engineering perspective, right? If you're looking at this, so I talked about already the V life cycle of the V model. So typically what you would do, you start out with a system as desired and end up with the system as built, and then you break things down, you work with the details, and then you integrate them back at the end of the day. And in our industry, we refer to them as user system requirements. It's even simplified. It's actually more than one step. The system architecture, the final design, the implementation, component or subsystem testing, integration testing, and then final verification validation. And so one of the challenges you face with integration is because quite often this was never done, right? And the same is true for the user and system requirements. Maybe operators were involved somewhat as part of the reviews, but not really the driver behind it. And so really what you can say is what's really lacking is the upper left. And the reason why is because, the industry starts right here, right with the disciplines. And so if you talk about conceptual design, you literally don't have much to go with. And so when it comes to integration testing, really what you need to be successful, you need to have a system architecture, and there's quite often none. And also, if you want to make sure that the system does what it was supposed to do, you need to understand what is it supposed to do from an operational perspective. Having said that, so truly, the early systems integration can be achieved if all of this is done up here, up front. And quite often the industry calls it to shift left, meaning it's whatever you want to do at the end, right? You move it to the forefront. That's really what this means. And so during preliminary engineering, and then moving on right through plans, specs, and estimates to final design, construction, operation, maintenance, and depending on the type of contract nowadays, we have what's called design build quite a bit. You would go to bid with a conceptual design. Sometimes you go to bid at the final design, right? It depends, but the important part is to make sure you have an integrated design at the beginning, fully understanding what you want the system to do. So let's take a look at the digital engineering framework. So as we spoke earlier, right, if you have all the different user groups and disciplines doing their thing, their own little documents, the whole idea of going from a document-centric, this is really what this means, to a model-centric approach, in our case, model-based systems engineering, is to make sure we all look at the same information, right? And the way it's done is in the digital environment. And then you would have all the different folks, whether you have operations or you have testers, you have the designers, right? You have other stakeholders. They all look at the same information, and you show them the information they're interested in. So how would this work? So starting on the upper left, right, with the information over here, you would go in model-based systems engineering. This would pretty much reflect what you see on the left side. So you would have the users, you would have the system, and then normally you would break it down immediately into subsystems. However, right, acknowledging the industry is broken down into disciplines, we would first break it down into disciplines, and then each discipline typically is responsible, if you recall, for communications, for example, for a number of systems. And then what you're trying to accomplish is obviously an integrated set of requirements, integrated conceptual design, where you can then go to bid, and then the next contractor would come up with basically working out the details of final design, and then you can go to construction, and you have the confidence at the end of the day that you can actually integrate everything. So what are the key activities? Just full disclosure, I'm just showing a few. We have not that much time today, but I would be happy if you're interested, if you want to follow up with me. So the first thing is you have to understand all the stakeholder needs and requirements. And users are stakeholders, but not all stakeholders are users. Yeah? So that's why you also have to focus into the user requirements. And typically you do this by looking into the operational concept. How do you envision the system to be used at the end of the day? Then once you start breaking things down, right, this is really what happens here, and you will have to, remember, integrate them back at the end. You need to understand the interfaces between, not only between, but even external, the users, the stakeholders, other systems. And then obviously we will have to work, right, this is what the integration team would do, but we will have to work with disciplines, with the SMEs, the subject matter experts. So we will talk about the collaboration, integration with their engineering design. And then also at the end of the day, once that preliminary engineering conceptual design was produced, you want to make sure that all the work you have produced up here is actually addressed, because that will go into the RFP or the bidding process. And technically, this information becomes, in most contracts, reference information, right, as input into the actual bid documents. So let's step through the different application of the 5 steps I just showed you over here. So the first one, you remember, identifying the stakeholders. So really, really important is to understand first, what is the system boundary? Where does it end, right? So you have to draw a line, but often it's called the system context diagram or boundary diagram, and then identify all the different stakeholders. And that's important because you now need to reach out to those and identify what the needs are. And needs could also be constraints by saying you cannot do this, like negative requirements if you want, but without going through all of them. But you can see, obviously, you have typically, we as a consulting company, we have a contract manager, then you're working with the engineering groups, the actual operators, maintainers, local residents, if you start doing a lot of construction, right? The businesses, if you close down, like streets and access, the public, obviously, media, you name it, right? Security, safety, regulators, all the different emergency departments, all of those have a way of either supporting or stalling your project. And then what you would do is you would start collecting those requirements. And so now we jump right into the details of digital engineering. And so what I'm doing over here is I'm just showing you a couple of those stakeholders. So the first would obviously be our own scope. What are we supposed to do? Then strategies you develop. Quite often you have safety, security, right? Then you develop analysis. It could be as simple as like a code analysis in civil engineering, or some others like a RAM analysis. Then once you do a safety, security analysis, you have mitigations. On larger programs where you do a lot of construction, you have environmental mitigations to take care of. And then I have to say, in this industry, a lot of information is hashed out in meetings and workshops. So you want to make sure it's technically not the way to officially collect requirements, but we have to work with the reality. So we meeting minutes, very important, understanding of where the requirements come from, what the stakeholders want. And also quite often, once you go through reviews, you get feedback and saying, don't do this, right? And if it's nowhere else captured already as a requirement, you might even capture comments as directions, so to speak. What you see over here, I'm just saying in generally, right, requirement number 1, number 2, number N, and then saying the scope of work, or the safety, security, and you name it. So what you see is really requirements management. And so what you want to do is you want to give everyone a single ID, but this is what the, what the digital engineering already does for you. This would also be a really good time to start developing a common language. As with every project, people come from all different backgrounds, different industries, different experience, sometimes different countries or continents. It's really important to speak the same language. So all I'm showing in here is if you really just the abbreviations like scope of work, right, or safety, security. This list will become very long. And one of the things I would recommend is to really enforce it and make that publicly available. So once you have a requirement, at least initially captured, the question is, so who's going to do it? And so what you will have to do is to first identify which ones are real requirements. Because if you recall that the plans and specs, clients typically have their own, or owners their own standards already. And quite often they're rather overshare than undershare. And in case they're concerned, you might claim of having not gotten all the information, but it also means quite often you get information that is not applicable to your project. So you should really try to whittle it down and saying what's in scope, what's not. And then the way the documents are written also quite often contain a lot of useful information, but it's only information. Some of the requirements are more like program related, like create a scope of work, a schedule, pay your subconsultants, whatever. They are not really requirements for the actual project or system that you're building. And then the other ones, right, we refer to those as technical requirements or technical contract requirements. So you have to find those, identify those first. We talked about disciplines already, so now you become more specific and say, hey, this requirement is part of the architecture group of a communications discipline. Then you even identify the actual systems later on, and then to make it crystal clear, even the designer, you really want to have accountability and say, oh, I thought this was somebody else. Yeah, no. You want to be saying this is your requirement right over here because that would be you. And then also, depending on where you are in the life cycle, quite often early, you might get information that is not necessarily to be done in your project just yet. So you still have to capture this and then make sure that you carry this requirement into the contract for the next contractor to do. So it's important to understand, is this going to be PE or preliminary engineering, final design, construction? And last but not least, what's also recommended, if you work in larger programs, you will have multi-contract environments. Make sure you clearly identify which contractor is responsible. Is it the trains? Is it the stations? Is it the civil contractor? Right, very important. Anyway, so this typically can be done in requirements management tools. But one of the benefits of a digital environment is that you have everything in the loop. If you recall earlier, everything in one place. So instead of just typing this into an Excel sheet or so, you can start breaking down the system. Can you see this? A system. Now we have more specific disciplines, and now you start developing the actual systems per discipline. So now you can actually make use of those, and the way it would work. You would use that requirement over here, right? And then saying this system, this would be one over here, will satisfy this requirement, meaning that I become the owner as a system, but also again, right, as I talked earlier, the designer. So that system is now the responsibility of the designer. And so indirectly, you would know that this designer is responsible for meeting this requirement by using that system. And those are dependency relationships in the model, and they will grow over time. Of course, you will have to come up with a plan of how you want to do all of this. But the interesting part is that you can really, once you establish all of those relationships, you can really run very effective queries or searches in the model. So going to the user requirements, you remember the actual users of the system. Typically, a mission control center is an example over here, but in transportation, this is an example of rail. You would have quite a number of different control centers. You have operations control, you have incident, which is safety, you have security, you have building management, you have a number of wayside facilities, which I'm not even showing here. And then for each of those, you would have a number of different users, right? For example, for operations control, you would have signal operators, power operators, the train set operators, not the ones on the train, but the ones basically being the counterpart of the control center, a public address coordinator, in this case, operator, and then the same, right, for all the other ones over here. So can you see, this is all about safety or hazard. So you have all the emergency responders like fire, police, emergency. Then security is all about CCTV, cameras, threat detection, providing access to secured rooms. So this is all about police. And then if you have buildings, you would have power, cooling, ventilation, escalators, right? All of this needs to be managed. And so how would you go about writing or extracting, or we call this eliciting those requirements from the users? Well, there are standards for that. So I like this quite a bit, IEEE 1362. It's already from the 90s. But what it does, and here it identifies things you should be doing. For example, the modes of operation. People have a tendency to think of the worst case scenarios first. What if it's blue moon, right? A leap year, a Sunday raining outside, and I'm losing my keys, then this is what happens. So the idea is to really focus on the normal operation first, right? The simple ones, and then you move to emergency. What happens if a train derails, or right? What if you have to take certain equipment out of service? Let's say you have a station, you have to take a track out of service for maintenance, failure modes if something breaks, right? Even a control center, what would you do? And then you take those modes right over here and start developing scenarios. Just the name right now, right? Train arrival, train departure, you have a safety incident, you have, for maintenance, you have health monitoring, you have scheduled or preventive maintenance, and you have something that breaks, so you have corrective maintenance. And then what you would do is you would develop for those more details. And so can you see this, what you would say, this scenario, you'd say, hey, this is, let's say, the public address operator. And the idea is to write down step by step by saying, at this site, the operator or user uses the system to do this. And so applying this to a public address operator, you would say at the OCC, the public address operator uses a public address system to make manual public address announcements. So it's not, this is not about to get the Pulitzer Prize, this is to write requirements, to make it clear. Another example, emergency, right? In this case, it would be the ICC incident command. You remember the emergency operator, in this case, let's say, uses a mass notification system, and then to issue mass notification to the public. And then a second one, right? In this case, the mass notification would now use a public address system because you don't want to have a system twice. So now that you have identified operationally what you want to do, now it's time to turn this into technical requirements. We call them system level use cases. And the idea is to say, hey, this is now my system, public address, right? And this would be the one over here. You have a public address operator. This is a function over here of a use case. The second one is coming from down here. And this, in this case, a mass notification system would tell PA to do something. And then they all, right, interact with the passengers by making announcements. And this one would be the mass notification system. I'm just showing two over here. So clearly it says the emergency operator, yada, yada, right? You get the idea. And so I can tell you if you do this properly for all the different scenarios, you will have dozens of scenarios and hundreds of use cases at the end of the day. And the idea now is, I'm showing this obviously just for simplicity for 2 systems and just a handful of functions, would be to collect them all at the end of the day, because public address and mass notification system, depending on how your organizational structure works, could be all communication systems, or it could be also that this is like a file safety system. But at the end of the day, now that you have this information in the model, you can start creating tables which populate automatically. This is really the benefit of a model. So you're saying, these are all my use cases. Can you see make public announcement, this one over here? Then you determine again, is this in scope and technical? You could say, of course, right, because I'm doing this specifically for this project. This is the discipline and this is the system who owns it. So this is already the time when I say, so now you did some extra work, and then who is responsible for implementing this? So moving to step number 3, interfaces. So if you recall, right, we just looked at this, the actual functions of the system. So this is a different graphic, actually. It says use case diagram. This is a different one, but the idea is to now develop a context for one of the systems, in this case, public address. And so what you have is here, because you have a user interacting with the system, you have a user interface. Now you have another system interacting with you that becomes a system interface. And then you still have stakeholders, right? You can also, if you want, you can call them stakeholder interfaces, but at the end of the day, the whole idea is to make the passengers aware of announcements, using announcements. And so what you would do now, now that you know you have an interface using this one over here, right, for the system interface between the mass notification system and PA. Now what you would do is, right now you know only there is something. And so in terms of interface level of detail, you can go to any detail you want, depending on the needs of your project. But basically what you're saying is, these are the 2 systems. You can see different disciplines over here, and then you identify an interface. And the easiest way to imagine is like if you have a laptop, right, you have a USB interface, you have a power interface, you have a network interface. So one system can have many interfaces. So in this case, I'm just, for simplicity, creating one, and that interface gets assigned to the system. And then you can even determine messages you want to go over the interface. For example, in this case, it would say MNS to PA, right? MNS is the mass notification system to PA. It even shows you direction in here. You can even say what the message is, the data over here, right? And then you can, if you want, to even define the data that's to be exchanged. And why is it important to go to this level of detail? You remember multi-contract environments. You might have those systems into different contracts, right? And you want to make sure they build to the same standard. Then over here, right, once you have the interfaces identified, you can create N2 charts automatically out of the system. And again, the system can create tables for you with all the interfaces, who owns them, which system, which interfacing system, the data to be involved. And then collaboration. So let's talk about step number 4. So everything you have seen before, the requirements, there's tools for that. This will be a web interface, like a wiki page you can click around. You can upload the glossary, right? You can upload the breakdown structures, the use cases, the interfaces. If I'm going back for a second, in here you would be able to make comments if you want to allow. So this is truly a simplified view where people can start sharing the same information using a web-based interface. And we fully acknowledge, right, in the real world, not everyone, we will not, it's not black and white. We still work with quite a number of non-systems engineers, so we can also export information and present this in a more readable format. This would be exported to Excel and PDF, and we can share this information via SharePoint and other means. Last but not least, for preliminary engineering. So now what we're doing is, now that we have completed the system level design, you want to say, what does it mean to the specific discipline or system? In that case, we grab one for the PA system. And so this is an IEEE standard for a system requirements pack. You don't have to do it this way, but you can. My preference is to use standards. And then you look at this, right? So already the system context, what you would typically describe in words, you can actually take a model element and plug it in there. The system functions, those are the use cases. You can talk about the user characteristics, right? The PA, a public address operator, others if you want to. You can go the external interfaces. We identified already that the PA system will interface with the mass notification system. You have system modes. So for example, a failure mode, if you have a backup, amplifier, if one fails. You have the acronyms. Again, for the sake of time, I will not be able to show everything, but the point is, all of the information you're looking for, you will develop very quickly in the model. And then what you can do, right, taking the use cases become functional requirements. And at the end of the day, what you will do is you will be able to turn those into what's referred to as well-written requirements following, there's a guide for writing requirements from INCOSE. It's the International Council on Systems Engineering, and then apply the characteristics, rules, attributes, right, making sure you have crystal clear requirements. But we are fully aware, right? This would be the MBSE way of the digital engineering, and we work in the real world. So how would this work with a plans and specs approach, right? This one over here. So what would happen typically in most projects, you have the SMEs developing the design criteria manual. You recall earlier, and this is organized by disciplines again, alphabetically sorted over here. Don't want to exclude anyone or prioritize. The drawings, and then even specs later on. And then I'm just showing some content over here, right? For communications, you would have system 1, 2, 3 for the drawings, the same thing. And then the idea would be to say, hey, let's go back to all the requirements, including the use cases, the interfaces. Show me everything that's applicable to me, right? I'm the COM1 system designer, for example, and then link the actual design criteria, drawing specs to it. The way it would look like, first you would use dependencies again, in this case a verify, and then you would create what's called a requirements traceability matrix, right? And then over here, can you see this would be the requirement? You have seen this one below already. Now we linked the DCM of the design criteria, the drawings, using the verify. This would be over here. And once you have that, you can see everything in one shape, in one table. And then there's quite some let's say buzzwords going on with digital threads right nowadays. So let me show you. We have established already a digital thread. We're starting out with a public address operator, right? With the operational scenarios, you have a PA operator here. Then you would say, okay, this PA operator, right, works with the PA system. So look at this, you can follow it to the PA system. The PA system has those functions over here, right, the two use cases. And then lastly, those use cases made it all the way into the requirements document. And you can do this any shape and form. You can also go backwards and saying, hey, where does this requirement come from, right? And you will understand, you can even understand of whom you should talk to. And this is a map view. We can also present this in a table view. And it's really powerful, that's all I can say. Last word, we are not ending at preliminary engineering. This is the life cycle. You can do this all the way to the end. I actually applied this in one of the projects, all the way to system acceptance testing, where you link the requirements to the use cases, to the behavior of the system, and all the way to the test cases. You can link it always back to the requirements, and that is really powerful. In case you're doing only quote unquote digital engineering during preliminary conceptual design, you would then have to hand over your model to the next contractor and would have to describe various aspects of what you want them to do, right? Without going into the detail. Having said that, final summary. What I showed you is basically a background of the industry, right? The plans, specs, and estimates. What the key challenges are typically when it comes to integration, so that we shift left and apply an early systems integration approach. That the digital engineering is really making sure everything is in one place, everyone sees the same information, it will become super consistent, and then stepping through the 5 steps: the stakeholder needs requirements, the user requirements, the interfaces, integration management, right, how we collaborate, how this would roll all into the actual preliminary engineering deliverables, and then lastly, that this is not the end and you can keep going. And final conclusion, that early systems integration can be achieved by applying a digital engineering framework. Thank you very much. I'm almost in time. Any questions?
Well, thank you so much, Oliver, for a great presentation. We have some questions in the chat box. So the first one will be, which tools do you use for doing MBSE, and do you have any examples where the client also wants to use and see the models, so they want to use it as well and have it handed over to them?
Yes, yes. So MBSE, actually, I have to, is a word, but it really means 3 things. You need to have a methodology, you need to have a tool, and you need to use a language. So the tool question, right? Quite often, obviously, engineers. So we're using Cameo Systems Modeler, but there are other tools available. We're using SysML, Systems Modeling Language, as the language. And there are a couple of methodologies available, but really, if you want to apply this to the industry, you have to customize it almost. So my recommendation is, right, because lots of people see this the first time, try to keep it as simple as possible, use the standards available. There are also other tools from other vendors which are compatible to SysML. So let me put this way, I don't want to mention the project, but yes, we have done this fairly recently in a big project in New York, multi-billion-dollar program. I did this before on another project actually, where I was kind of doing this behind the scenes. But then once the client became aware and saying, oh, this is good, right, we should hand this over to the next contractor. And so in those two projects, the one was right up front, the client said, hey, if you're doing modeling, can I see the model? So we actually shared the model using the web client, as you could see. This was the the way the client, at least some of the client members, right, the systems engineering folks on the other side, would even access the information, the requirements, the interfaces, the use cases, and then distribute this internally. And the intent is to take this model and then put this into the RFP, and then have ambiguous requirements, not necessarily for the system, but what you would expect the next designer to do. Right? You would say, these are the, typically you have milestones, and let's say during this milestone do this, developing, let's say, the context diagram, the requirements, the interfaces, and during the next, right, you would start developing test scenarios, test cases. So long story short is, yes, we have done this. I'm not sure I feel comfortable in mentioning exactly the client, but we have, whatever you have seen here, we have done before, including sharing the model with the intent of giving it to the next contractor. And if you were to switch to a different industry, let's say defense, they even call it model-based acquisition. Yeah, it's a real thing where you would respond actually as a bidder in a model, just to even demonstrate that you are able and capable of doing this.
Okay,
Next question.
Yeah, sure. Before continuing with the questions, I just want to remind the audience that you have a copy of the slides now in the handout box that is available for you to download. The next question will be, great presentation, Oliver. Thank you. Is it common to have a system or subsystem involving multiple disciplines? Then would you capture it under both or under one and make it that party responsible?
I mean, I have to say in management, even in general, right? You never want to have two people responsible for one thing, because the chances are somebody misunderstands. So my vision would be to break it down to the point where I can clearly assign it. Yeah, it would be perfectly fine if you have one system breakdown and even a discipline breakdown. And then the system can break it down to the subsystems, to the system elements, or even going down to what the industry recalls like line replaceable units, or lowest level replaceable unit. And then saying, even if it's one system, you're saying this component over here is discipline A and this component is discipline B. But that also means that you're basically, even if it's within the same system, you would now have a discipline interface. And it could even go as bad as that this becomes part of two different contracts. So my recommendation would be break it down until it becomes a clear ownership.
Perfect, thank you. Next question is, great diagrams and MBSE in this presentation. Are your clients find values in using MBSE, or will you keep it internal, helping you deliver what clients will typically require? Often clients don't have the, often clients don't have the expertise to maintain or own the models, and they wouldn't be interested in spending money on MBSE or architectures in general.
No, I actually see interest, yeah, but clients typically are not capable to this in-house, even if it always comes down to willing and able, right? Even if they're able, let me put this the other way, even if they're willing, quite often, we work with transportation clients, if they had to procure something, it would take a long time, yeah, getting internal approvals and setting something up. And then if they have an in-house solution, they would have to get give contractors access to it, and if something changes, they would have to be able to quickly respond to it, which is typically not the case. Yeah. So what clients would do is quite often make one contractor responsible. So one of the terms that's quite often used is like a common data environment. And so they would say, hey, you contractor, if it's one contractor, that's easy enough, right? I want you to do it, but you will have to provide all the tools and the training and the licenses. You see this quite often, yeah, that you expect the contractor to do the work and to make all the arrangements, to share this, and then even provide the licenses for the owner or client to get access to it. And if it's a multi-contract environment, you typically pick one of the contractors to do it. And so I can see interest. I mean, I can tell you, even if you're not sharing this with the client, already by doing this behind the scenes, you become, it's very, the consistency is much increased. Yeah. And so what I did is in one of the projects, quite often you have a number of diagrams, and then you can replace those diagrams or the pictures in documents with one from MBSE. And really the biggest benefit is if you establish consistency. You come up with your design terms, and then whether you're on page 50 or 250, it's the same naming, not nomenclature. But I have seen clients actually, even if just becoming curious, yeah. Sometimes we call it systems engineering or MBSE curious, but say, hey, what are you doing over here? Oh, this looks good, right? And so but if you don't know what this is, how would they know? Yeah, so you have to start slowly, very simply introducing it, making sure that you communicate the benefits, and then clients are actually quite open, I have to say. Yeah.
Okay, next. Does WSP have a requirement MGMT tool?
So you mean MBSE or something different?
It says MGMT, maybe yes.
So we work. What happens? Yes, we do. Yeah. So we actually, obviously I wouldn't be able to show all of this if you didn't, right, have the tools available. But also what happens is, depending on your projects, your clients might have different ways of doing business. So even the one of the clients, over time, you started off with the requirements management tools, let's say Requisite Pro, and then Doors and whatever. Yeah, there's nowadays different ones. Even as what I was saying earlier, I don't want to sell a product or so, but whatever your client, what your client standard is, either you buy it for you or you buy it for the project, and then you work with those tools. But yes, we do have that tool available. We have the licenses, and we actually move towards model-based requirements management because, again, right, by having everything in one place in the model, you can link the requirements directly to the users, to the actors, the use cases, the structure, the interfaces, the test cases. Everything is in one place, which is really highly beneficial to do.
Thank you so much, Oliver. We are just in time, so we have a couple more questions, but I'll make sure I send it to you so you can address them. You also, the audience, have your email here, so you can reach out to him, of course. You want to say any words to finish?
Yeah, thank you for your interest, and so I'm sure some of you I know definitely, right, from prior adventures. Just keep up the good work of in basically introducing and maintaining systems engineering principles in the projects, MBSE, moving towards digital engineering. And any questions you have, please reach out to me. I'm happy to answer them. Thank you so much for your time and interest.
Thank you, Oliver. Thank you, everyone. Have a very nice rest of the day.
Thank you.